In this lecture, we are going to discuss about the properties of interior of a set in a matrix space. Properties of interior. First is interior of A. Interior of A is the largest open subset of A, okay, where A is the subset of a matrix space. Hence, proof. So interior of A is the largest open subset of A. First, we will show that interior of A is open. Then we will show that interior of A is the largest open subset of A. Okay. So first, we shall show that we shall show that we shall show that interior of A is open. Okay. If interior of A is empty, we have nothing to done. Interior of A is open. If interior of A is empty, then we have nothing to do. Interior of A is automatically open. So right, if interior of A is empty, then it is open. Then it is open. So let interior of A is not empty. Then for all x belongs to interior of A, there exists some real number are greater than 0 such that SRX is a subset of A. Okay? This SRX being open sphere, this SRX being open sphere, and we know that every open sphere is an open set. This is open sphere, so open sphere is open set. This is open set. Since SRX being open set for all y belongs to SRX, there exists some real by using the definition of open set. Z is open if for all x belongs to Z, X is the center of some open sphere, SRX containing Z for some r greater than 0. So using this definition of open set, we will get some r1 greater than 0 such that SR1y is a subset of SRX. Okay? Now, this subject. And we know this SRX is contained in K. This implies SR1 Y is contained in. If this happens, we can conclude that this Y belongs to interior of A. That means for all point Y in SRX, there exists some real number R1 greater than 0 such that SR1Y is contained in SRX. SRX is contained in A. So SR1Y is contained in A. When SR1Y contained in A, that this implies Y belongs to interior of A. This is by the definition of interior of A. And from here, we have seen that Y belongs to open sphere SRX, Y belongs to interior of A. This implies SRX is subset of interior of A. We have seen X belongs to interior A. Center at X, we will for some real r greater than 0, we will get open sphere that is contained in interior of A. This satisfies the definition of open set, so interior of A is open. interior of A is open. So right, interior of A is open. Put this equation 1. Next, to our proof will be complete if we show interior of A is the largest open subset. Okay, for that we will consider any open subset of A, that is, then we will show that this subset will be subset of interior of A. Then we are done. Interior of A will be the largest open subset. So consider, let G be any open subset of A. We are going to show that interior of A is the largest open subset, that is, our G will contain in interior of A. For that, consider for all x belongs to G, as G is open, there exists some real number are greater than 0, such that SR x is contained, this open sphere is contained in G, as G is open subset of G, open subset of A. So this G contained in A, that means this open sphere ultimately contained in A. This implies SR x is a subset of A. That means this x belongs to interior of A. I have considered x initially in G. I have found x belongs to interior of A. That means my G open set G is a subset of interior of A. Given any open set G, open subset G of A, that will contain in interior of A. Therefore, interior of A is the largest open subset of A. Here, from 1, we can conclude that interior of A is open. From 2, we can conclude that interior of A is the largest open subset of A. Therefore, from 1 and 2, from 1 and 2, interior of A, interior of A is the largest open largest open subset of A. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.